Hey everyone, and welcome. Today, we're getting our hands dirty and building something that's becoming absolutely critical for anyone working with AI, guardrails. As we plug these incredibly powerful models into our applications, we have to make sure they're not just smart, but also safe and reliable. This is how we're going to do it.
So, I want you to imagine this. You've just launched a brilliant AI chatbot on your e-commerce site. It's there to help your customers, answer their questions, and maybe, just maybe, help you sell more stuff. Everything's going great. But then, this happens.
Your AI, in an attempt to be helpful, does something kinda terrifying. It makes things up. This is a classic example of what we call an AI hallucination. It just invents a 50% off discount code out of thin air. And the result? Well, you've got angry customers, a support team in total chaos, and a huge dent in your brand's credibility. This right here is precisely the kind of failure that AI guardrails are built to prevent.
Okay, so here's the game plan for today. We've just seen a perfect example of an AI going rogue. Next, we're going to architect a real solution to stop that from happening. Then, we'll roll up our sleeves and actually code both an input and an output guardrail, piece by piece. And finally, we'll see how it all comes together in a complete protected system.
Let's start with the blueprint. Before we write even a single line of code, we have to think like an architect. We need a solid plan. How do we design a system that can safely manage the immense power of a large language model? How do we build that safety net that catches these problems before they can do any real damage?
So what even is a guardrail? At its heart, it's basically a security checkpoint. Think of it as a bouncer for your AI. It's a layer of logic that inspects every single thing going into the AI and every single thing coming out of it. Its one and only job is to enforce your rules and your safety policies, making sure the AI behaves exactly the way you want it to. This little diagram here shows the entire flow of information. It all starts when a user sends a prompt, but, and this is key, before that prompt ever reaches the AI, it has to get past our first checkpoint, the input guardrail. If it's safe, it goes to the model. The model does its thing and generates a response. But wait, that response doesn't go straight to the user. Nope. It has to pass through a second checkpoint, the output guardrail. Only if it passes that final inspection does the user actually see it. This two-gate system is the fundamental architecture of a safe AI app.
All right, time to build that first gate. The input guardrail is our first line of defense. It's all about protecting our system from bad stuff from the user before the AI even gets a chance to see it or be influenced by it.
Our first goal here is a big one. We have to stop something called prompt injection. This is basically an attack where a clever user tries to trick the AI into ignoring its programming and doing something it really shouldn't, like spilling system secrets or generating harmful stuff.
Okay, let's look at some real code. What's so powerful about this is just how simple and effective first step can be. We're defining a Python function here, isInjectionAttempt. Inside, we just create a list of keywords. These are the phrases that attackers love to use. The real magic is in that return statement. It's a neat bit of Python that just loops through our keywords and checks if any of them show up in the user's prompt. We use .lower to make sure it's not case-sensitive. If it finds a match, the any function returns true. And boom, we flagged a potential attack. Simple, but effective.
And here's the payoff. Look at the difference. Without our guardrail, that malicious prompt goes straight to the AI and who knows what it might be tricked into revealing. But with our simple function in place, the input guardrail immediately spots the phrase "ignore your instructions," flags it, and just blocks the prompt entirely. The attack is dead in the water before it even begins.
All right, our next job for the input guardrail is just as crucial: protecting user privacy. We never want to process or store a user's sensitive personal info. Things like email addresses, phone numbers, credit card numbers, unless it's absolutely necessary and handled with extreme care. Our guardrail can help automate this protection.
So how do we do it? Let's check out the code. First, we import Python's R library, which is for regular expressions. Now, if you haven't used them, just think of a regular expression as a super-powered search pattern. This pattern here, /s plus @/s, is a basic way to find anything that looks like an email address. The real work is done by r.sub, which finds everything matching that pattern and just substitutes it with our placeholder text, redacted email. It's a clean, powerful way to sanitize your data on the fly.
The impact of this is crystal clear. On the left, a user's private email goes straight to the AI model. It could get logged, stored, or who knows what, creating a big privacy risk.
But on the right, our guardrail jumps in, automatically scrubs the email out, and then passes the clean, anonymous version to the model. The AI still gets all the context it needs to be helpful, but it never even sees the sensitive data. Problem solved.
So we've secured the front door. Now it's time to put a guard on the back door. The output guardrail is our final quality check, our last chance to make sure that whatever the AI cooked up is safe, appropriate, and helpful before it ever gets in front of a real user.
A huge job for the output guardrail is to basically act as a content moderator. We need to be absolutely sure the AI's responses are never offensive, hateful, or just plain inappropriate. We can start by scanning its output for toxic language.
And hey, this code should look pretty familiar, right? But the context is totally different. This time, we're checking the AI's output, not the user's input. We define a function is toxic with a simple list of banned words. Now, in a real-world system, you'd probably have a much longer list, or maybe even a whole separate classification model for this. But as a first-pass filter, this simple keyword check is an incredibly valuable and super easy to implement safety measure.
And this is the crucial part for the user experience. When our guardrail flags a response as toxic, we don't just throw an error message. That would feel broken. Instead, we intercept that bad output and we replace it with a pre-written, safe, and helpful response. This way, we maintain a positive experience for the user while making sure our app stays within its safety boundaries.
Okay, we've built the individual pieces. Now let's zoom out and see how it all comes together. We've taken a vulnerable application and transformed it into one with a really robust safety architecture. This quote really nails why this is all so important. This isn't just about catching errors or preventing bugs. It's about something much deeper. It's about building trust. When your users know that there are safety systems in place, they're much more likely to rely on, engage with, and ultimately get value from the AI tools you build.
So let's just take a look at our report card. We started with a clear set of risks. Prompt injection, our input guardrail mitigates that. Private data leakage, mitigated. Harmful or toxic content, our output guardrail takes care of that. And this brings us right back to our original problem, that made-up discount code. We can absolutely solve that with an output guardrail too. We could write a rule that checks if any coupon code the AI generates actually exists in our company's database of valid codes. If it doesn't, we just replace it with a helpful message. See? We've closed all the loops. Look, if you remember just one thing from this whole explainer, let it be this number, 2. You need 2 guardrails, one for the input and one for the output. If you only protect one side of the conversation, you're leaving a massive door wide open. A complete safety system means securing the entire journey of data, from the user to the model and all the way back again.
So let's wrap this up with the key takeaways. First, guardrails are not a nice-to-have, they are absolutely essential for any production-ready AI. Second, they have to act as filters on both sides of the model, input and output. Third, as we saw with our code, even simple rule-based checks can be shockingly effective at stopping big problems. The trick is to start by defining your policies, what you want to allow, what you want to block, and then turn that logic into code. And finally, remember that this job is never really done. It's a continuous cycle of refining and updating your rules as new challenges pop up.
And that brings us to a final, really important thought. Everything we've built today, it's like building a strong fence around a garden. It's absolutely essential for protection. It keeps the deer out, it keeps the bad stuff out. But a fence by itself doesn't make a garden grow. And that leads to the next big question for all of us.
Building guardrails is the foundation. It's defense. It's about preventing harm, which is step 1. The next, and I think far more exciting challenge, is to move from that defensive posture to a creative one. How do we actively shape AI to be more helpful, more insightful, and a true collaborator for humanity? Building these safe systems is what gives us the license to explore that future. Thanks for watching.